If we move to part B now, we have a rectangle with its base on the x-axis, and this one's inscribed under the graph of cosine. I again want to find the dimensions of the rectangle with the largest area, and this time I also want to know what the area is. So I've got two things I'm finding this time. I want the dimensions, and I want the max area. So the setup is going to be the same as it was in part A, except instead of having a parabola, I'm now under the cosine graph. So I need to know that the cosine intersects at pi over 2 and at negative pi over 2, and I can draw a rectangle that straddles that y-axis. Again, the distance from the origin to the right side of the shape will be x, so I can label a point here as x comma cosine of x, and I can set up the formula for my area, which will be the base, which is 2x, times the height, which is cosine of x. If I want to take the derivative now, since I have a calculator and this is a multiple choice problem, I can do it on my calculator. So again, I'm going to go to my y editor, and I'm going to clear out what's in there and put in my new function, which is 2x times the cosine of x. Now I've got my first function, which is the area. I've got my derivative in y2. I need to know when that derivative equals 0. So I'm going to show you how to do the other version on this one. So I'm going to turn off y1, and I'm going to think about the domain. If we look at this picture, x can get as small as 0, and x can get as large as pi over 2 before we run out. So my domain on this is between 0 and pi over 2. So that means I'm going to set my window. I'm actually going to graph and look for my derivative on this one. So I'll go to my window. I can look from 0 to pi over 2, and then I'm going to do a zoom fit. This will take a little while. Little graph for me. We're looking for when that derivative crosses from positive to negative. You can see it's coming down. It crosses there. And now my goal is to locate that x coordinate. So to do that, I'm going to use my math menu, which is F5. I'm going to look for the 0. It asks me for a lower bound. That means I need to locate the 0 and move to the left, and I'm currently blinking on the left, so I'll hit enter. The upper bound means I need to be to the right of that number. So even though it looks like it's underneath, that's still an upper bound for the x value. And I can see that my XC, this 0.8603359, that's the location at which my area will be maximized. So I can write down my x coordinate, and then I can use the fact that that x coordinate is stored in the calculator's memory as XC until I find a different XC. So our goal, if you recall, was to find the dimensions and the area of that rectangle. So the area we stored in y1. So if I go to my home screen, I can compute y1 at that x coordinate of the 0 that I just found and is now stored as x alpha c. So if I hit enter on this now, that 1.122 is now the area of the largest rectangle. And the dimensions I can find by plugging that XC into the base of the rectangle, which is 2 x's. So 2 times XC's. There's my base, 1.721. And my height is the cosine of that x. So I'm going to do the cosine of x alpha c. Hit enter. I get a height of 0.652. Next is part C. Part C, I've got a rectangle with its base on the x-axis underneath the graph of y equals 2 sine of x. So this one's going to be a little different because the rectangle is not going to be straddling the y-axis. Instead, it's going to be offset. So I'm going to graph this y equals 2 sine x. That intersects at pi and goes up to 2. And there'll be a rectangle underneath it. Again, the x goes from the origin to the closest edge of the shape. So that's x. Symmetry will tell me this is x. Therefore, the base is going to be a pi minus a 2x. And the height will be the output of the function 2 sine of x. So our goal is to find the rectangle of the largest area. So area in terms of x will be the base, which is that pi minus 2x, times the height, which is 2 sines of x. If we think about the domain, the smallest x can be before I run out of rectangle is 0, and the largest x can be will be pi over 2, because as this x goes toward the center, this one is also going and will completely collapse by the time we get to pi over 2. So again, we need to maximize this, and we want, when we're done, the dimensions and the area. I will pull out my calculator and I will go in and edit and change my y1 to be the area of that rectangle, which was pi minus 2x times a 2 sine x. And then again, like I did in part B, I'm actually going to graph the derivative so that I get that xc and can use it. So I will set my window 0 to pi over 2, and then I will do a zoom fit and wait for the derivative to show. So notice on the picture, my graph of the derivative is changing from above the x-axis to below the x-axis. I need to find that 0. So I will use F5 to locate the 0. Lower bound means I need to be to the left of that intersection, and upper bound means I need to be to the right. Hit enter, wait for it to compute. Now until I find another xc, this will be stored in the calculator's memory, this 0.710 as the location of the max. So the question was, what are the dimensions? Well, the dimensions will be the base, which is pi minus 2xc, and the height, which is 2 times the sine of that 0, or xc. So on the calculator, we'll type in on the home screen pi minus 2 times x alpha c. So there's my base, which is 1.721, and then the height is 2 of those sine of xc's. So 2 times the sine of x alpha c. So there I get a 1.304. And then I also need the area. So the area will be that xc plugged into y1, because that's where I stored my area function. That gives me a 2.244. So my answers are, dimensions are 1.721 by a 1.304, and my area is a 2.244. The max occurred when x was 0.710. And I didn't write out the full explanation because it's a multiple choice. We don't have to have the justification.